Hello, this week I explain quantum mechanics. First one is one-wave properties of light. Light has three properties of wave. First one is interference, second one diffraction, third one is refraction. Interference is the phenomena where waves overlap, leading to the areas of reinforcement or cancellation. And second one, diffraction, is the bending of right around of circle. And third one is refraction. The change is in direction of light as it passes through different media. And second one is electromagnetic waves and speed. This one is wave equation. Ex, t E0 sine kx minus omega t. This k is a wave number and omega is angular frequency. Speed of light is c nu lambda omega of k. The frequency and wave number are used to determine the speed of light. And next is Young's double slit experiment. This experiment is light of this is light this one, and light has constructive interference, and second is destructive interference. Constructive interference has light is strong and destructive is cancelled, and light is picture. And first is X-ray diffraction pattern. Bragg's law is 2d sine theta equal n lambda. Explain this picture drawing, and if X-ray is go to X-ray, this is atom. This is atom. Atom has reflect the X-ray, so this detector. This is detector. Deflect theta is deflect angular is theta, and this between the atoms is between the atoms distance is d. So this is d sine theta, and this is sine theta because this is 90 degree. So Bragg's laws available. So 2d sine theta equal n lambda. And next, this is next 5 is photoelectric effect. This one is about intensity, and this one is frequency, about frequency. This one is higher intensity and lower intensity. Has higher intensity is have a number of electrons, higher number of electrons, but it doesn't measure electron energy. And this one is about higher frequency is mu3, mu2, mu1 has different voltage, and this one is same voltage. This higher frequency has it doesn't measure number of electrons, but higher frequency has higher energy. So we have result. Intensity of the light affects the number of electrons emitted, but does not affect their kinetic energy. And frequency, intensity of the light affects the number of electrons emit the photon effect and the frequency of the light determines the kinetic energy of the emitted. So the higher the frequency, the greater the kinetic energy. And increasing the intensity of the light increase the number of electrons emitted. And but the kinetic energy remains the same. Next one is 6 energy package and photon behavior. This is a photon energy is a photons which are package of bright energy have an energy that is directly proportional to the frequency of the light. Photon energy is nu. And next, Compton effect. The Compton effect refers to the scattering of the X-ray photons when they collide with electrons. This scattering leads to a change in the wavelength of the photons, which is called Compton shift. Delta lambda is equal half of mc 1 minus cosine theta. If photons collide with electrons, electrons have lost the energy, so electrons wavelength is long because electrons energy is lower than before. And next one is A, time independent of Schrödinger equation. Schrödinger equation is this like this, and half I is half of 2 pi, and psi x is the solution of equation, and psi square is a probability of density. And next, application to the infinite potential wave, like this. V is infinite and this is 0. So in this one, in the world of psi x is 0, like x and next energy level. Solving the Schrödinger equation for the infinite potential wave gives quantized energy levels that depend on the quantum numbers of n. Energy level is 8m 8a square n square h half square. And next one is 10, quantum tunneling. Quantum tunneling is phenomena where a particle can pass through a potential barrier even when its energy is less than the height of barrier, and something that is impossible in classical mechanics. This is quantum tunneling equation. A is the width of the barrier, V is the height of the potential barrier, E is the energy of the particle. And next, transmission coefficient and reflection coefficient. Transmission coefficient is the T, and R reflection coefficient is R equal 1 minus T, because properties sum is 1. When a particle encounters a potential barrier, there are the possibility transmission through the barrier. Transmission through the barrier is the quantum tunneling. This is the quantum tunneling, and reflection back from the barrier. And last one, scanning tunneling Microsoft STM. The STM is a device that uses quantum tunneling to image surface at the atomic level. Thank you.